Hello, everyone. Yes, my today's talk would be about running some benchmarks to compare Grafana Mimir and VictoriaMetrics. And my name is Roman. I'm one of co-founders of VictoriaMetrics, and VictoriaMetrics is an organization behind open source project called VictoriaMetrics as well. I'm a software engineer. I'm doing everyday software engineering work. I have experience in distributed systems. I have contributions to ClickHouse, for example, and yeah, I really like monitoring right now, and I'm working on VictoriaMetrics for the last 3 years already. And VictoriaMetrics is, as I said, time series database. It is open source, available on GitHub under Apache 2 license. You can run it as a single node, as a cluster version, and it is capable of really big workloads. We have about 11,000 stars on our repo, and big cool companies using VictoriaMetrics for their monitoring, like Roblox, CERN, Grammarly, Bix.com. So take a look. And I also will be talking about Grafana Mimir because Grafana Mimir is also an open source time series database, scalable time series database. It is distributed also via GitHub under different license, GPL license actually. And since both VictoriaMetrics and Grafana Mimir are doing the same work, like collecting metrics, storing them, and plotting graphs, it is like a good idea to compare them, right? So about a year ago, Grafana Labs published a benchmark where they scaled Grafana Mimir to collect 1 billion of active time series with ingestion of 50 million samples per second. These are huge numbers. It is like really high than really higher than top installations, and this is really cool benchmark. I recommend you to read about it. And to run this benchmark, they used like 7,000 CPUs and 30 terabytes of memory. So it's pretty expensive benchmark as well. So we read that benchmark and decided that since our products like doing the same job, it would be nice just to compare them to see how they behave on the same workload on the same hardware. So we decided we did the benchmark and we published it on our website. It is called like comparing VictoriaMetrics and Mimir. And today I'll be talking about these technical details of this benchmark. Small disclaimer: do not simply rely on the numbers that you see from this presentation or from other vendors or from other posts, because benchmarks like they are cool. You can learn a lot from the benchmarks, but usually those numbers will be different for you, for your installation, because you have different hardware, you have different data nature and data shape. So always try it yourself. And it would be cool if vendors of those solutions would provide you tools where you can emulate that workload so you can test it in your own case. So how do we compare these two different solutions? So both Grafana Mimir and VictoriaMetrics, these are two separate software, and they have different architecture. So it would be really hard to compare themselves, to compare them both, and it would be really hard to run another 7,000 CPU benchmark. So we were thinking that 1 billion of active time series is pretty high and above than average installation. So we decided just to take the similar hardware and take the average workload that many users have and to run both solutions to work with this workload. So we deployed Grafana Mimir and VictoriaMetrics using their original Helm charts into Kubernetes engine, into different namespaces, and both and this Kubernetes cluster provisioned with ETO standard 16 Google instances, each 16 CPU, 64 gigs, and SSDs. But there is also another tricky question here. Since they have different set of components with different resource usage profiles, we need to allocate resources between these components somehow. So in order to understand how to better allocate those resources, we need to understand also how architecture looks like for both solutions. So we start with Mimir architecture, and Mimir stores its data in object storage. Object storages are cool. They're cheap, bottomless, reliable, And this is what Mimir using for long-term storing. And also another cool thing that Mimir has a compactor, like a different component which monitors data in the object storage, and it recompresses it to improve compression, and also it can deduplicate data, so leaving one copy instead of three if you have replication factor of 3. So that's pretty cool. And how data gets to the object storage. So this is the write path for Grafana Mimir. So you have distributors here. These are stateless components which receive writes from the clients. Then they shard it, replicate it to multiple ingesters. And ingesters are components which actually contain state. They receive those writes, and they write this data into the memory, forming data chunks. And these data chunks exist there for like 2 hours in the memory, and then ingester flushes this as a data block on the disk. And then after some time, eventually, this data block will be uploaded to the object storage, so it can be queried after. Okay, this is write path, and this is read path. So read path serves read queries, the queries from QL queries which you execute in your Grafana or maybe in your alerting rules. And query frontends are stateless components. They receive these read requests, and then they can optimize those requests. For example, query frontend can split one request into 2 requests and send it to different queryers. And then queryers are actually a components which do PromQL evaluation. And to do this evaluation, they need some data, and they request this data from the store gateway. And store gateway is responsible for getting and managing data from the object storage. So for example, it maintains indexes and responds with data blocks to queryers. You also have a set of caches on each layer. These are optional, but they are included by default to the Helm chart. So this is read path. And this is like the full architecture where we have all this intercommunication between components. The cool thing here is that querier can also request data from ingesters, not only from the store gateway. And this is because ingesters contain in this recently written data. Actually, by default, ingesters contain like 24 hours of the data. And since most of the queries in monitoring are alerting queries, and alerting queries are queries which execute on the recent data, this totally makes sense. So querier doesn't need to read data from the object storage, which is slower. So it reads it from ingesters, which stores data in local file system. So that's Mimir architecture. And this is how we allocated resources for this architecture. So the most of resources we allocated to ingesters. So it was 5 replicas, each for CPU, 25 gigs mem, and distributors also, distributors which are managing writes between ingesters. And also 4 replicas of queryers, which have each 2 CPU, 24 gigs of memory, and the rest of resources allocated for caches, store gateway, etc. So in total, in this benchmark, Mimir got 43 CPUs and 283 gigs of memory. Okay. And yeah, we used 2.2 version of Mimir. Now, VictoriaMetrics architecture. So this is the storage layer for VictoriaMetrics. That's the only stateful component in VictoriaMetrics architecture. These are basically shards. So you can run with 1 VM storage, you can run with 30 VM storages. So think of them like database shards. VM storage stores data in the local file system. It doesn't have support of object storage, so everything is stored locally. On the right path, we have stateless component called VM insert, which receive writes from the clients, and then it shards and replicates data across available VM storages. And on the read path, we have VM selects, which are similar to query frontends. That's basically the component which evaluates PromQL expressions. It receives requests from the user, validates it, checks if any limits were exceeded or not, requests data from the VM storages, and does processing in the memory and respond to the client. And that's the resource allocation for VictoriaMetrics. So we allocated 44 CPUs, which is one more than for Mimir, and 208 gigs of memory, which is 80 gigs less than for Mimir, just because we have like different components with different profiles. Okay, and also important question, how you put the workload on this cluster, because in Mimir's blog post, for example, they used tool called K6, and K6 like a framework where you can do where you can write any benchmark you want. And for their benchmark of 1 billion of active time series, the script of K6 is looks artificial because it generates only integer values and only counters. But in fact, if you check, for example, Prometheus metrics or NodeExporter metrics, they contain like 20% of counters only. The rest are gauges or histograms or summaries. And it is rarely you see like integer in values of the metric. It's usually floats. So we use Prometheus remote write benchmark tool, which is developed by VictoriaMetrics as well. And we believe that this tool is far more better for testing, specifically for monitoring use cases. Because what it does, it generates more production-like workload. And if you go by this link, you will find the explanation what is production-like workload and how data shape affects the compression and the processing speed in time series databases. So let's try to understand how this benchmark works. So as a source of data, benchmark doesn't use artificial data. It doesn't generate it. It uses NodeExporter as a source of data. And NodeExporter is one of the most popular exporters in Prometheus ecosystem. Probably if you're using Prometheus or Thanos, Cortex, Mimir, or whatever, you are also using NodeExporter to collect metrics from your infrastructure. So NodeExporter here generates us real looking like production data. And then we have a metrics collector called VM agent, which collects, scrapes basically data from NodeExporter and pushes to the remote storage via Prometheus remote write protocol. And also we have a caching layer because NodeExporter seems kind of expensive. If you will try to scrape it like 100 times per second, you will likely see delays on the scraping. So we use Nginx just to cache for a couple of seconds these scrapes. So we can easily easily scale the workload to hundreds of millions instead of thousands. So this is write pass and read pass. So for read pass, we decided to also to follow the common case. So if you have NodeExporter metrics, you probably also use alerting rules for NodeExporter metrics, which are shipped with NodeExporter together. So VM alert is a ruler, basically a thing which evaluates alerting rules, and we've added with default alerting rules for NodeExporter. So each request from the remote storage, it evaluates these alerting rules every 10 seconds or whatever you configure it, reads data back. And altogether, it looks like this. So we have write pass, read pass, and also we have one VictoriaMetrics single node, which scrapes metrics from both write and read pass, just to understand if everything works fine, if there are any errors, what are latency for reading data, and etc. So benchmark, quick stats. So the benchmark was going for 24 hours. That's good iteration, but it would be even better to run it for 7 days or something or even more. That's how you get like true numbers. But running benchmarks is complicated. It could be expensive and complicated to make everything right. The benchmark generated like 360K samples per second of ingestion and 5.5 million of unique time series. And also it was configured with non-zero churn rate. And churn rate is like the effect when some time series are stopping to exist and are replaced with new time series. So if you are using Kubernetes, this is really similar to application redeploy, because when you redeploy your application, it deployed with new pod names, and pod name is usually a part of a metrics label. So when you redeploy something, you actually create a new time series. And this churn rate is the biggest enemy of modern time series, because it generates you can see that over 24 hours, 5.5 millions were transformed into 13.6 millions of unique time series. And this this big number of time series, it bloats indexes and makes your databases slower. But churn rate is a thing which you can't eliminate if you're using Kubernetes, probably. So every time series database should be able to handle this. And over 24 hours, we also ingested 31 billion of samples into both databases. So how it looked like? Well, for both solutions, it looked really well. Like everything was smooth. There was no hiccups. Both solutions did it really stable. No any issues were spotted. How it looked like from disk perspective for Mimir. So for Mimir, you see it a bit spiky. So like every 2 hours, something happens. And this is exactly the event that I told that ingesters hold data in the memory for 2 hours, and then they create a new data block on disk. So they need to flush this data from the memory to the disk and start creating new block. So this is what happens with disk when you run it with Mimir. Every 2 hours, you see these spikes. And this is a cool thing that Mimir receives data in the memory, because this is called like write deamplification. That means that you accumulate data in memory instead of trashing your disk, because disks don't like frequent requests. It is better to accumulate data in batches and write them as one. For VictoriaMetrics, it was far more stable because VictoriaMetrics doesn't have this 2-hour behavior. VictoriaMetrics accumulates data for 1 second and flashes it every second, making data parts on the disk, and then does background merges of small parts into bigger parts. So for VictoriaMetrics, it was like more stable. Disk space used. So you see that by the end of the benchmark, VictoriaMetrics was like using 6 times less of disk space. And I said that Mimir stores data in the object storage, but I also said that ingesters store data locally, like a recent data for 24 hours. So that was basically the disk space occupied by ingesters. And also Mimir using object storage. So for object storage, it was like plus 150 gigs uploaded to S3 bucket. Oh, sorry, to Google bucket. So in total, it was like 300 plus 150, and VictoriaMetrics was like 50 gigs. But it is a tricky question because these numbers are not, like there are many details which could affect these numbers. So for example, for Mimir, we used replication X3, which is a recommended replication for Mimir. And for VictoriaMetrics, replication was X2. So basically, VictoriaMetrics was receiving 2 copies of data when Mimir was receiving 3 copies of data. In the blog post, there is like a wide explanation why VictoriaMetrics needs X2 replication, not X3. In 2 words, like it allows in both cases with replication X3 for Mimir and for VictoriaMetrics replication X2, you can lose only 1 storage node or ingester in case of Mimir. So this is the parity on availability here. But there are more to say about this, and you can read it in the blog post. Also, this disk size occupied by ingesters. So by default, it is 24 hours, but you actually can reduce it. You can say that store it for 4 hours and something like that. And the disk occupied by ingesters will be reduced. Also, compactor component, which runs next to object storage, it has like multiple intervals to work on. It is 2 hours, 12 hours, and 24 hours. And since benchmark was going on only for 24 hours, probably the last compaction cycle didn't happen. So on the long run, the storage could be more efficient for Mimir. And also, the cool thing about compactor is that it deduplicates replicated data. So we write 3 copies of data because replication factor X3, but on the object storage, after some time, compactor will leave only 1 copy of the data and will remove other 2. So on the long run, Mimir will compress data really good, I suspect. I don't know exactly, but from the documentation, it looks like this. It looks efficient. So for VictoriaMetrics, disk space usage was 50 gigs for the same data, but with replication factor X2. And what else VictoriaMetrics can do with disk space? It has downsampling, so you can specify that you want to store raw data up to 30 days. After 30 days, you want to store only 5 minutes resolution, and after 6 months, you want to store only 1 hour resolution. This is the usual case because data for 6 months rarely queried, and you don't need that oftenly. You don't need that high resolution. So this reduces disk space occupied significantly for installation, which has like 1 year retention, 5-year retention, etc. And also VictoriaMetrics has this retention filters where you can specify via time series selector which data you want to store for what period. For example, dev environment, I want to store it for 3 days only. For staging environment, I want to store metrics for 30 days, and all the rest metrics storing for 1 year. So this also can improve disk size. And yes, disadvantages, VictoriaMetrics doesn't have this object storage support. Everything is stored in local file system, and it stores both copies of data with replication factor x2. Doesn't have this cool feature from Mimir. Okay, CPU used during benchmark. So VictoriaMetrics used on average 12 cores, and Mimir used 20 cores on average. So not much to say here. Both are stable. VictoriaMetrics more efficient here in terms of CPU usage. In terms of memory usage, difference is far more bigger, and it would be like right to compare max values, not average here, because that's what you usually do with memory. If it's not enough memory, you can get out of memory exception. So let's compare max, and here VictoriaMetrics efficient like more than 6 times. 6 times less memory was used for the same workload. And this is how memory utilization looks for Mimir. So you can see that there are many components there in the legend, but mostly memory was utilized by ingesters. Like ingesters are the most expensive components here in this setup, and they were like using up to 90% of memory at spikes. And this is also a sign that you can't actually scale benchmark more after that, because you will start getting out of memory exceptions. You need to add more resources if you want to increase workload, or you can reshape the resource allocation as well. And for VictoriaMetrics, memory utilization was kind of low. For storage nodes, it was up to 13%. So there is a room for scale. Read latency. So remember, we have this VM alert, which runs alerting rules asking for data with some specific interval. And for Mimir, 99th percentile on average was 35 seconds, and median was like below 100 milliseconds, which is kind of cool. And for VictoriaMetrics, it is a bit different. So 99th percentile was twice less, but median was almost twice bigger. But on average, I would say that read latency kind of the same. So the stats of the benchmarks. Mimir used about half of the CPU resources, 20 out of 43 CPU cores, and about 120 gigs of memory for during this benchmark. VictoriaMetrics used less. It used 12 cores of CPU and only like 20 gigs of memory from allocated for this specific benchmark. Now, as I said, VictoriaMetrics had some room for increase of the workload. Not everything was utilized. So on the next phase of the benchmark, I tried to add more load. We keep in the same configuration, just increasing the benchmark params. So what I did, I increased load by 5 times to 1.8 million samples per second of ingestion and up to 29 million of active time series. And benchmark was held only for 3 hours. I didn't capture rest, but only have 3 hours. So over these 3 hours of the benchmark, total number of time series growth to 32 millions, and we ingested like 19 billions of data points. You can see that it was stable. Ingestion rate was stable. There was like a small hiccup at the beginning until until caches probably filled. But on average, it was like 1.8 million per second samples ingested into this setup. Active time series are on every it marks like 58 millions. I said before it was 29, but replication factor x2, which means we ingest 2 times more data, so it doubled 58 million active time series. And here we started to hit the ceiling in terms of CPU. So the most of CPU was used by VM storages. So VM storages are the most of resources used by VM storages, because storage layer is responsible for both read and write loads, and also for compressing the background. So if you want to scale VictoriaMetrics cluster, you would like to add more resources to the storages, or just to scale it horizontally. So you can have not 10, you can have 30, 40 storage nodes, and with adding of each storage nodes, you will get this horizontal scalability. Everything will be multiplied. So here we hit this CPU limit. That means that we can't longer increase the ingestion speed, because storage can't keep up. And memory utilization was still below 50%, which means we could probably increase the number of active time series, but ingestion rate should be the same. We also can reshape a bit configuration to reallocate, but yeah, that would be a different benchmark, and this is why it is recommended to run your own benchmark, because we don't know in advance what is your workload. So in total, over the 3 hours, we utilized 26 cores out of 32, and maximum memory usage was like 69 gigs out of 200 gigs. Read latency was busted, of course, because it was not enough CPU for VM storage to handle the read loads. So median was about 17 seconds, and 99th percentile was about 2 minutes. If we want to improve this, we need to scale VM selects to add more VM selects, and also add more CPU to VM storages, so they can keep up with ingestion load and responding to read queries. This is materials which I used during this benchmark. So if you go to the blog post, you will see that it contains all the configuration params used here. So all these are links to the gists mostly, where you can check which exact configuration params I used for both first and second part of the benchmark. You can see, you can find a Helm chart overrides, and what is even more better, that we have snapshots for Grafana dashboard. So all these screenshots that you've seen here, these are basically snapshots that you can explore yourself, because they are publicly available. You can click on the link and see how benchmark gone for yourself. It contains much more information than I showed here. So you can explore it, and that's how snapshot looks like. It contains a link to the benchmark itself. It contains all the charts, and also next to each chart there is an info button. When you click on it, you can see the exact query which was used to plot this. So if you are curious about what's happening during this benchmark, you can explore it and understand and repeat for yourself if you want to compare. So remember I said about 1 billion is too much. So recently there was a talk from Roblox. They were using VictoriaMetrics for storing their data, and actually they are ingesting 120 millions of samples per second, and they have 5 billion of active time series in their installation. These are cool numbers. These are probably biggest numbers I've seen used for VictoriaMetrics. I haven't seen such numbers for other solutions. So yeah, also you can check this talk at, it was given by Roblox team at Grafana Labs conference this year, like a month ago or something like that. Also, what we have here, there is another benchmark made by our CTO, where he scaled VictoriaMetrics cluster, and also a benchmark to 100 million samples per second. So it was given like a year ago or something like that. There is a video and slides. You can explore that as well. And yeah, that's mostly it. Here you can find a link to our blog post, a link to the benchmark blog post itself, link to Roblox talk, but I should warn you that it requires email. Grafana Labs requires your email to sign to get it. And yeah, please check out our project.